Hello everyone. In this lecture, we will delve into an essential machine learning technique known as logistic regression. Logistic regression is a statistical method used for predicting binary outcomes. It is particularly useful in predictive analytics for estimating the probability that a given input belongs to a certain category. This lecture is tailored for those embarking on their journey in data science and machine learning. This lecture provides an intuitive understanding of logistic regression as a first step. In this step, our goal is to provide you with an understanding of what logistic regression is all about. Next, a concise mathematical explanation of logistic regression is provided. Our goal in this step is to give you a rough idea of what mathematical elements of logistic regression. At this stage, it is not necessary to understand mathematical details. It is enough to get a sketchy understanding. Then, in the last step, we will go deeper mathematically into the logistic regression analysis. This in-depth mathematical explanation will comprise the bulk of this lecture. Although it contains advanced content, the explanation is designed as easy to understand. By the end of this lecture, you will have a deep understanding of logistic regression. Chapter 1: Intuitive Understanding. This chapter focuses on gaining an intuitive understanding of logistic regression, particularly its application in binary classification problems. Logistic regression is a statistical method that models the probability of a binary outcome based on one or more predictor variables. It is commonly used in scenarios where the response variable is categorical, such as email spam detection or predicting whether a customer will make a purchase. Actually, logistic regression can be extended beyond binary scenarios, but this lecture focuses on binary scenarios for simplicity. Consider two primary examples: filtering emails as spam or not spam, and predicting customer behavior as purchase or not purchase. In a classification problem, each category of the outcome variable is called a class. So, spam mail filtering contains two classes, spam and ham. And the two classes in the customer purchase prediction are purchase and not purchase. Both scenarios require us to classify each observation into one of the two categories. The challenge lies in making these predictions accurately based on available data. You might wonder, why not use linear regression for these classification tasks? Linear regression predicts values within a continuous range, but classification problems require a categorical outcome. Herein lies the crux. Linear regression cannot directly model the probability of class membership, since its output can extend beyond the range 0 to 1. Logistic regression, however, is specifically designed for classification. It models the probability that a given observation belongs to a particular class, fitting the predicted values neatly within the 0 to 1 range, making it exceptionally suitable for binary classification problems. Let's take a visual look at the suitability of logistic regression in binary classification. First, let's look at the plot on the left. There are positive cases in the upper right corner of the plot and negative cases in the lower left corner. This means that the higher the value of the predictor x, the higher the probability of being positive. Since the outcome of the binary classification is 0 or 1, the value of y takes 0 or 1. Let's look at the plot in the middle. A straight line does not seem to approximate the relationship between x and y for this data. Moreover, Outputs of linear regression can take any value, but the probability takes only between 0 and 1, so it cannot be fitted as an outcome variable. So, a linear regression model does not represent the relationship between x and y. Let's look at the plot on the right. This S-shaped curve better approximates the relationship between x and y. Logistic regression is a model that represents the relationship between predictor variables and outcome with an S-shaped curve like this one, called a sigmoid curve. So logistic regression is more suitable than linear regression for binary classification. Let's understand the theoretical underpinning of logistic regression without delving into complex formulas. There are two underpinnings: probability modeling and decision boundary. The first underpinning is probability modeling. In a binary classification, the outcome consists of two classes called a positive class and negative class. A positive class usually means present, happen, or yes, and a negative class means not present, not happen, or no. The words positive and negative do not relate to goodness or badness. Logistic regression estimates the probability of an observation belonging to the positive class. In email filtering, the positive class is spam, so logistic regression estimates the probability of an email is spam. The second underpinning is decision boundary. Logistic regression establishes a decision boundary. That is, a logistic regression model defines a threshold value to classify observations. If the predicted probability is above this threshold, the model classifies the observation as positive, and if below, it classifies it as negative. In practice, logistic regression helps in making decisions with binary outcomes. In email spam detection, logistic regression analyzes features of emails, and using those features as input, logistic regression predicts whether an email is likely spam, helping in filtering unwanted messages. In customer purchase prediction, logistic regression can predict whether a customer is likely to make a purchase based on their interaction with a website, guiding targeted marketing strategies, and so on. The advantage of logistic regression lies in its ability to provide probability for classifications, offering not just a binary outcome but insight into the confidence of their prediction. This is crucial for making informed decisions, especially in areas where the distinction between classes is not clear-cut. Logistic regression is a useful tool for binary classification where we want to predict outcome variables consisting of two categories. In other words, we can use logistic regression to predict which of two categories an observation will be categorized. Logistic regression uses one or more predictor variables as input and makes a model that predicts the probability of each observation belonging to each class. Then, if the probability of an observation is above the threshold, the logistic regression model classifies the observation as a positive case. Logistic regression is a powerful tool because it generates highly interpretable results. It provides not only binary outcomes, but also probabilities for classification, enabling us to make informed decisions, especially when the distinction between classes is ambiguous.